Okay, just looking at some hard inverse trig sketches. So if we have y equals sine the minus 1 of sine x. Now the first thing you've got to look at is the restriction on the domain. So if you look at sine x, there is no restriction. So the domain is all real x. The range, however, the range is y is the sine the minus 1, therefore the range is restricted by the sine the minus 1 function. Just the sine function, see that looks like that, that's why that's all real x, but the sine the minus 1 is what the y is equal to. Looks like this. So it's restricted between pi on 2 and minus pi on 2. So when we're looking at this, if we let a, say, equal sine x inside that function, then you've got sine the minus 1 of sine x. So it's sine the minus 1 of a. That means that a equals sine y. So now we have a is sine y and a is sine x. So you can only conclude that sine x equals sine y. So that means that the y will equal x. So y equals x looks like that. But because the domain is restricted, that means that it's going to be a. I mean, the domain is not restricted, it's all real x. You're just repeating this basic function. And it has to go between pi and minus 2. Minus pi on 2. So really important just to look at the domain, and that will tell you, like, it's either going to be this one or this one, because that will wipe those out, because it's got to be all real x. This one's telling you that when you're looking at these, the possibilities is A or B. If you look at sine the minus 1 of sine x, though, if you put in like a negative x, something in the second quadrant. So if you look at the quadrants, so sine is positive in quadrant 1 and 2, but it's negative in quadrant 3 and 4. And that means that's between pi and 2 pi. So if you look at wherever we're going between pi and 2 pi, see how it needs to be negative. Here, if you go between pi and 2 pi, you can see part of it's positive, part of it's a negative. Sine the minus 1 of sine x is also an odd function, because sine minus x equals minus sine x, and so that gives you sine x, so that would be sine the minus 1 of minus sine x, and the same thing happens with that one too. So it turns out to actually be like an odd function, so that's another reason why it would be a. Alright, so looking at the cos of cos the minus 1 or the sine the minus 1 of those, I want you to just to think about those is that they are going to be zigzag curves. And the reason they are going to be zigzag curves, and if you put it onto Desmos, just have a quick look at it, is because the cos and sine one, when you look at the domain, it is all real x. So there's no restriction. Whereas when you look at the range of the cos the minus 1, the range is the y has to go in between 0 and pi, because the cos the minus 1 graph looks like that. Whereas the sine one, that's all real x. But the range, the y value, has to go in between minus pi on 2 and pi on 2. So this one here is going like a zigzag between pi on 2 and minus pi on 2, whereas this one's going a zigzag. But, sorry, it's not going to be like that, because it's got to go between pi and 0. So like going like that. Okay. Whereas these ones here, the domain restriction is the sine the minus 1, which looks like that. So that one's going to go between -1 and x and 1, whereas the range restriction for a sine, so it's this one here, a basic sine curve, would be between -1 and 1. So these ones look like little things like that. And the same thing happens with the cos. The x restriction is between 1 and -1, and the y restriction is between 1 and -1. So it's going to be pretty much a very similar curve. Okay, so looking at this here, this is a cos and a sine one. So you've got cos the -1 of sine minus sine x. Okay, so if you look at that then, the x restriction, that will be all real x, except they've then restricted it between -pi on 2 and pi on 2. And all of these graphs, so you see that's what they're between anyway, so that's going to really help. The range, it's a cos the -1. So cos the -1 is restricted between 0 and pi. So the next thing to think about here then is if you let a equal sine x, then you get y equals cos the -1 of minus a. So that means cos y equals minus a. So a is equal to minus cos y. So that means that minus cos y equals sine x. So cos y would equal to minus sine x. So that's cos y equals sine of minus x, sorry. So y would equal minus x, but it is restricted in the domain. Okay, so I'm just going to take that back and think about to here. If it didn't have the minus in there, it's actually going to be a normal cos the -1, but it's going to be flipped because of that. So the normal one would go this, like normally it goes this way, but it's going to be a y the minus x, so it's going to flip. So the answer is actually going to be D. You could also think about it as if you brought that in with the y. And then that's cos y equals sine x. But I think the main thing you've got to think about here is that the graph is actually flipped. Because it's like having, it would be like having y equals cos the -1 of minus x. That would mean it would go the other way. So it'll be a flipped graph. One of the best things you can do though is substitute in a point. So, like if you put in x equals pi on 2, then you get y equals cos the -1 of sine of pi on 2. Sine of pi on 2 is 1, cos the -1 of 1 is equal to pi. And that's, see, that's giving you that one up there, not this one here. So D. Alright, so with this one here, the restriction on the x is in between 1 and -1, because it's a sine the -1 graph. So if you let a equal sine the -1, then a equals sine the -1x, then x equals sine a, and so that's y equals cos of a. So therefore y equals x, but the domain is restricted between 1 and -1, and the y is a cos graph. So the range is also restricted between 1 and -1. So it's going to be like that between 1 and -1. And the same as this one, let a equal cos the -1 of x, cos a equal x, and then you've got y equals sine a, because you're just replacing the cos x with the sine a. So that means that y will equal x, because y equals sine a and x equals sine a. But because you're looking at this original one, the x is restricted between 1 and minus 1. And because the y is a sine function, the y will be restricted between 1 and minus 1. So it's a line, y equals x, between 1 and minus 1. So then that'll be between 1 and minus 1 on your domain as well. Okay, so for this one here, you can see that 3 on x is restricted between 1 and minus 1. X cannot equal 0 because that's on the denominator. So 3 on x is greater than or equal to minus 1. So if you make that equal 3 on x, you get minus x is 3, or x is minus 3. That's one critical point. And 3 on x is less than or equal to 1. So 3 on x equals 1. So that means 3 equals x. So that's another critical point. So go 3 minus 3, 0. They're coloured in. That's open. So let's just try a point. If you put in x equals, say, 4, then 3 on 4 will be in between 1 and minus 1. So I'm just putting it into here to see if it's true. So x equals 4 will work. X equals minus 4. Minus 1 is less than or equal to 3 on minus 4 is less than or equal to 1. That works. And then I'm just going to try something that's inside here. So if I put in x equals 1, minus 1 is less than or equal to 3 on 1 is less than or equal to 1. That's not true inside. So it's got to be on the outside. So it's going to be A. Now, just a refresher on these dilations, just in case. So y equals cos the minus 1 of x minus 3. It's transformed where it's horizontally dilated by a scale factor of half. So a scale factor of half means you have to do f of 2x. So that means where the x is, you're going to put 2x. So it's going to be 2x minus 3, because I'm just replacing the x with 2x. And then we want translated to the left by a scale factor of 1. So it's to the left, it's going to be f of x plus 1. So that's cos the minus 1 of 2x plus 1 minus 3, which is cos the minus 1 of 2x plus 2 minus 3, which is cos the minus 1 of 2x minus 1. And that's it.